Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 20th, 2025, about 4 days ago. It lays out a fully transparent two-stage recipe for multimodal reasoning, combining supervised fine-tuning with reinforcement learning, and reports an 11.6% improvement over the QN 2.5 volts L7B instruct baseline across 9 multimodal reasoning benchmarks. The paper is titled OpenMMReasoner, Pushing the Frontiers for Multimodal Reasoning with an Open and General Recipe. And as we dig into the details, the implications for how we design and debug reasoning-focused training pipelines are quite significant. Also, the authors shared a full GitHub repo for OpenMMReasoner. You get the complete SFT and RL training pipelines, a bundled Virl fork, data processing code, and scripts to download datasets, launch training locally or with Ray, and run multimodal evaluations using LMMS Engine and LMMS Eval, plus example configs to copy. On Hugging Face, you will find OpenMMReasoner, 8 billion parameter cold start and RL checkpoints, plus Python snippets for image, plus text chat inference using QN 2.5 VL. Figure 1 makes a headline result concrete. The red bars for OpenMMReasoner reach the highest accuracy on every benchmark, from MathVerse through WeMath. This figure shows the grouped bar chart where each benchmark has several competing models, and the red bar is always tallest, which signals consistently stronger multimodal reasoning. The gains are especially striking on WeMath and MathVista, where accuracy climbs close to 80%. Alright, figure 2 spells out how the whole training recipe actually flows, from raw data all the way to the final reinforcement learning policy. A cold start pipeline means the initial supervised fine-tuning path that bootstraps a capable model before any reinforcement learning happens. The left half shows data sources feeding into a selected teacher model, which generates step-by-step answers and mixes in cross-domain data. The right half shows that cold start model going into data filtering, then careful algorithm design, and finally producing the optimized reinforcement learning recipe. Table 3 shows that sampling multiple answers from the teacher for each question, which the authors call repeated teacher sampling, clearly boosts downstream reasoning scores. The full table compares 1, 2, 4, and 8 samples per question across 3 MathVision benchmarks. Performance steadily climbs as answer diversity grows, with 8 samples giving the best average and the strongest scores on MathVision, MathVerse, and MathVista. So more varied teacher traces create a richer supervised fine-tuning dataset and noticeably better reasoning. Figure 3 explains how the training recipe spreads its attention across different kinds of data, which really underpins the strong reasoning performance. The left donut chart shows the supervised fine-tuning pool, dominated by general visual question answering, with substantial slices from math and text question answering sources. The right donut chart shows the reinforcement learning pool, which leans heavily on general and science reasoning, plus math and puzzle visual question answering. Together, these distributions indicate a deliberate balance between broad visual understanding and harder structured reasoning tasks. Table 6 makes the payoff of the training recipe very clear, because it shows accuracy on many visual reasoning benchmarks side by side. This table compares cold start supervised fine-tuning models, reinforcement learning-based models, and closed-source systems. The highlighted OMR cold start row already outperforms other supervised fine-tuning baselines, with under 1 million supervised samples. The bottom highlighted OMR reinforcement learning row then pushes scores to the top or second place on most benchmarks, while still using relatively modest supervised and reinforcement learning data sizes. Table 7 shows which reinforcement learning recipe actually delivers the strongest visual reasoning given different cold start datasets. The key message is that GSPO, with 16 rollouts from the richest cold start, which mixes image and text math, achieves the best average scores across benchmarks. Curriculum-style sampling and higher rollout temperature hurt performance, or even destabilize training, so the final configuration keeps simple, mixed sampling, moderate temperature, and enough rollouts for stable learning. Wrapping up, 2 takeaways stand out. Carefully curated, supervised fine-tuning data, plus a stable group sequence policy optimization reinforcement learning recipe can dramatically boost multimodal reasoning, and doing it all in a fully open pipeline makes those gains reproducible and extensible. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.